Let us see the detailed explanation of the code how to dynamically hedge European call option in Python. To revise that from the previous discussion, first we have to estimate the parameter like volatility and other parameter. At inception or at t is equal to 0, we calculate the initial theoretical price of the call option. Also, we compute our delta. This is the number of position on the share. We have to. Then we set the initial portfolio in this way. We can see that the theta or the position in the risk-free asset will be given by this amount. Therefore, the initial price is given by this. The initial portfolio is given by this. So in other words, the portfolio should have this amount invested in the stock, and the remaining will be invested in the risk-free asset. So the next step, at t is equal to t1, s of t1 is realized from the market while we choose our portfolio in this way. So we calculate this again, delta t1 from the cumulative distribution function, and our theta will be obtained by satisfying this equation. So we produce this until the maturity. So here, to simulate the delta hedging, we define a function to generate the geometric Brownian motion. The assumption is the stock price follows the geometric Brownian motion here. So this is to obtain different paths by taking the parameter as indicated here. So this is a function to generate possible paths. So the next function here is for dynamical delta hedging, right? So what are the inputs? The inputs are time to maturity, sigma is the volatility risk-free, the strike price, number of options, and also the possible paths, which is simulated for geometric Brownian motion. So at line number 50, we discretize the time step into the length of, which is equivalent to the length of paths, right? Length of paths. And our delta t will be the difference between time 1 and the time 0. That means just the length of the time step. So we create an array to store the call prices through different time, an array of length t. Also, we create an array of length t for storing deltas, and also portfolio values for each time step. The stock price, which is, of course, it is the path. Also, we create an array of zeros for storing the cash required to cover for buying a share, or if it is surplus, it is positive, we deposit it into the bank account. Then this is P and L for tracking the profit and the loss. Especially this is significant at maturity. It must be closer to 0. That is the objective of hedging. So using our formula, D1 is given by this one. That means logarithm of initial price S0 divided by K. Okay, this is up to, okay, this is for all time. You see the paths, we take the paths, possible paths. Okay, here D1 is an array of these. When the possible prices change, D1 also changes through time. Then the call values, applying Black-Scholes-Merton formula. The call values, when the price change through time, we obtain different call prices. So you see here, this one represents S of t, the price of the stock price, and this one is the CDF, or the cumulative distribution function, evaluated at D1, and D1 is also changing through time. K is the strike price, and so on, as you can see from the video. Also, the call or the call price at maturity is equal to -1, means at maturity or at the end of the array. It is maximum of 0, or the price at maturity minus K times number of options. So our deltas can be calculated as the CDF of D1. It is an array of length t. So our deltas from the 0 to the end is equal to this delta. That means here we create deltas of size length t, then the values is given by this delta after calculation. Actually, this is a repetition. I think it is possible to do like this one. Directly we can calculate this, but it is okay also if we put as this. So the initial portfolio is C0, okay, the call value initially. So our initial investment in the stock is equal to the price at 0, delta 0 times number of options. That means this is a investment in the stock. That means delta times S0 times number of options. So initial investment in the risk-free asset, that means the portfolio, the initial portfolio minus the value invested in the stock. And our P&L will be this one initially, which is cash 0. So this is rebalancing. For example, when I is equal to 1, that means at t is equal to 1, this and at t is equal to 2 up to at t is equal to maturity, we will apply the rebalancing step. So this is stock I, means the value invested in the stock, that means S times delta times number of share, and the remaining here theta, our theta is here, that means the amount invested in the risk-free asset. Here that is equal to, just apply the formula we did there directly. So then our portfolio value at the ith step will be the value invested in the stock plus the value invested in the risk-free asset. So this is the cash. The cash will be portfolio value minus the value invested in the stock. And this is a calculation of our P&L, which we already showed in the previous slide. So our P&L is given by, at maturity is given by this one, which is also indicated in the slide. So then just to create a data frame, okay, to create a data frame of table, which I will demonstrate just now. We make the following: create a table of data frame with index of time, then column for price, that means the path, column for the call option, for delta, and for portfolio value, for the value of the stock, and the bond portfolio, or that means the cash, and the P&L. So here, this is example. Let's say this is a path, possible path for 20 weeks, and I think this is a possible path of stock price. Let's say the number of option is 1, and the volatility is 80%, risk-free interest rate, and time to maturity is 20 weeks. So apply that means call the function dynamical delta hedging here by inserting the necessary parameter. So you will get a table. So what is a table? Looks like, you see. So this is the table for this price, means the path, possible stock price. This is when the price of the stock changes. The call option, the price of the call option also changes. So this is the price of the call option at the inception. So 0.7 or 70% of the share should be bought. Then the portfolio value is equal to the initial call price, which is 2.6. The stock, therefore, this value is, remember, this 24.84 is obtained by 0.76 times this delta times the price, right, which is equal to this one. Then we already sold 2.6. Then the difference between this one and this one will give you negative 22. So this will be obtained by borrowing, or by borrowing from the risk-free asset, which is negative. So we'll continue this one. And if you see the table at the end of the 20 week, right, you have 0 P&L, and the portfolio value is 2.5. That means we there is no profit and there is no loss, and the value of the portfolio is maintained. So this is very nice example, and one can repeat and practice for other possible scenarios. Thank you very much.